In this video, we introduce inheritance. Inheritance is a big idea in any object-oriented language, including Java. As a brief review, a class is like a blueprint of what an object will look like. When you create a class, you create a new data type. You define the characteristics and functionality of objects of this type with instance data variables and methods. Variables specify what the object looks like, and methods specify what the object can do. Inheritance allows us to create new classes based on existing classes. Inheritance allows us to reuse the characteristics and functionalities of an existing class in a new class. Inheritance involves a parent class, also known as a superclass or base class, and a child class, also known as a subclass or derived class. The child class inherits all of the characteristics and behaviors from the parent. This is how we can reuse the existing code. Inheritance represents a hierarchy. Inheritance should be used when you have an is-a relationship. The child class represents an object that is an example of the parent type. It's just a more specific version. A child object has all the characteristics and behaviors of the parent type, and then it also has more specialized characteristics or behaviors. Some classic examples of inheritance relationships are student and graduate student. A graduate student is a student. It's just a specific kind of student. Book and dictionary. A dictionary is a book. It's just a specific kind of book. And bank account and checking account. A checking account is a bank account. It's just a specific kind. You declare a child class with the extends keyword in your class header. The child class inherits the instance data variables and methods from the parent. You can then further develop the child class by adding new methods and variables and/or modifying the inherited methods. A child class inherits the variables declared in the parent class. In this example, the student class has a private instance data variable for name. The child class inherits that variable, so a graduate student object also has a name. However, if the parent class variables are declared as private, which they should be, and they are in this example here, you cannot directly access those private variables in the child class. They're still there. They're still part of what defines a child object, but they cannot be directly referenced in the code. In this example, if we were to try to access name or this.name, the child class would not compile. The only way to access these inherited private variables from inside the child class is with the public inherited getter and setter methods. Another option is to declare variables in the parent class as protected instead of private. This will allow the variables to be accessed in the child class. But it does not provide as much encapsulation or data hiding as when you declare the variables as private. So use protected visibility with caution. Parent variables and methods are inherited from the parent class into the child class. The only part of the parent class that's not inherited is the constructor, even though it has public visibility. The child class does not inherit the parent constructor, so a child class needs its own constructor. But the child class will use the parent constructor in addition to having its own. Rely on the parent's constructor to set up the characteristics associated with the parent. The child constructor can then invoke the parent constructor with the super keyword. Invoking super calls the parent constructor. After that, you can add code in the child class constructor to set up additional characteristics that you defined in the child class. In our example, the student class constructor would invoke the parent constructor to initialize name and any other parent variables. We would then add additional code in the graduate student constructor to initialize any variables we declared in the graduate student class. Note that in your call to super, it has to be the first line of your child constructor. The child class must invoke some parent constructor. If you do not have an explicit call to super like we just saw in the previous slide, then behind the scenes, the zero argument parent constructor is called. If that happens, and if the parent constructor doesn't have a zero argument constructor, if the parent class doesn't have a zero argument constructor, then the child class will not compile. The child class inherits all methods from the parent class. These methods represent the functionality associated with the parent type of object, and any object of the child type inherits this same functionality. The child class also has the option of overriding the inherited method. Overriding a method means replacing or changing the functionality that's inherited. When you override a method in the child class, it's because you want to do something different from the parent version, or you want to do what the parent version does, but then do more. In our example, we might have a method called printinfo in the student class. The graduate student class inherits this method, so a graduate student object has the same functionality as represented with the printinfo method. We can choose to override the method in the graduate student class if we want to do something more or do something different. To override it, we create a method in the child class with the exact same method signature, meaning the same method name and parameters. In this case, public void printinfo with no parameters. It's best practice to use the @override annotation on all overridden methods. This is optional, but it's best practice. Using the @override annotation puts a compile time check that you have written the correct method header. The annotation also serves as a good visual cue to someone reading your code that this method is being inherited, and possibly modified from the parent version. We override a method when we want to do something more or do something different. If you want to execute the parent's implementation and then do more, you can execute the parent version of the method using the super keyword again. You invoke super dot the name of the method to call the parent version of the method. Then after that, you can add on additional code inside the child version. Unlike when we use super to invoke the constructor, the call to the parent version of the method can appear anywhere within the method. It doesn't have to be the first line. If you do not invoke super.method, then the parent version is never called. The child version of the method then just serves to replace the parent version of the method for all child objects. Whether or not to override a method and whether or not to invoke the parent version of the method are important design decisions. Think carefully about whether the child object needs to change or modify or add on to the parent's functionality. Another important idea to keep in mind when designing inheritance relationships is to put common or shared variables and functionality as high up in the hierarchy as possible to maximize your code reuse. Variables and methods are inherited all the way down the hierarchy, from parent to child to grandchild and so on. So the higher up you can put common code, the more classes further down the hierarchy will be able to reuse it. When designing for inheritance, allow each class to manage its own data and functionality. Allow the parent class to set up its own variables and modify them as needed. The parent class should be in charge of its own data. You can always use the super keyword to access parent functionality from inside the child class, but code that relates to parent variables or parent functionality belongs in the parent class. Let the parent class deal with the parent parts of the object and the child class deal with the child parts of the object. And of course, before considering any of these other design decisions, make sure inheritance is the right choice for your classes. When designing classes that use inheritance, make sure you have an is-a relationship. All classes that you write in Java have a parent class. If you use the extends keyword in your class header, then you declare the parent. You do this to represent your is-a relationship. But if you do not explicitly declare a parent using the extends keyword, your class still has a parent. Your class inherits directly from the capital O object class. Class is the ultimate root of all class hierarchies in Java, so all classes eventually inherit from or derive from Java. In our example, the parent classes of student, book, and bank account, the parent class of all those classes is object. All classes inherit some common methods from the object class. You can override these methods to change the functionality so that it makes sense for your class. The toString method allows you to create a text representation of your object. This method is inherited from object, and you override it so you can define what that text representation should be. The equals method is another commonly used inherited method. When you override the equals method, you get to specify what makes two objects of your class logically equivalent to each other. If you use the inherited version, the equals method only compares if two objects are aliases, meaning they point to the same place in memory. But if you override the equals method, you can define equality to be a logical comparison of the characteristics that describe your object. We'll discuss overriding the equals method in more detail another time. One final note about inheritance. You can restrict inheritance with the final keyword. If you declare a class as final, you cannot extend it, meaning you cannot create a child class from that class. If we were to modify the bank account class header to be final, we would not be allowed to declare a checking account class as a child class. If we were to modify the dictionary class header to be final, we would not be able to create a child class of dictionary, such as Spanish dictionary. The other way you can use final is to restrict method overriding. In a parent class, if you declare a method as final, it means you cannot override that method in a child class. In our example, if the student class has a final enroll method, the child graduate student class could not override that method. This has been an overview of inheritance in Java. Inheritance allows us to reuse the functionality of existing classes. Reusing code rather than duplicating or recreating it is a best practice, and inheritance is one way to do that. Inheritance can make code easier to maintain by reusing parts of code across multiple classes. Inheritance allows us to create classes that represent realistic relationships between objects. I hope this inheritance concept is a super useful concept that helps you in your future coding adventures.